Hi Achievers, good afternoon. How are you all? How is everybody doing today? I can see Manjeet is here, Shivansh, Chitramani, Legend Girl, what's your name? Zarina, Tatleen, King, Saranya, Grisha, Prachi, Determination and Hope. Nice, Janani. Good afternoon all of you. Welcome back, a very warm welcome to this brand new session. Hey Vipul, Jashvika, Vasi. Welcome guys, I can see slowly all the kids are joining in. So what are we going to explore today? What are we going to study today? Well, we know that matter exists in solid form, liquid or gaseous form, right? This we know. Today, we will see what is the effect of temperature. What is the role of temperature? What's the effect of temperature on different states of matter? This is what we will be doing today. Hey Utkarsh! Shakil, King, besties. Who are these besties? Yes, good afternoon all of you. Abhay, noted. Divyamshi, Anchal, Zarina, Raj, Kavita. A very good afternoon to one and all. My diaries. Who is my diaries? I want to know that. You've done the homework question also. Prashansa simply loves chemistry. Hey Vishal. There's somebody named All Rounder as well. KY बहुत जल्द होगा. Bhakti, Rishi. Good to have you back guys. Alright, how many of you know about this BYJU'S the learning app? Let's see. Your one-stop solution, your one-stop source for literally acing the exam, I think. Hey Chitra, thank you so much. Rishi knows about this. Vasi is also saying yes. A lot of you saying yes, yes. So guys, you can always share your experience, and this app is simply wonderful. You will get everything out there. You will get unlimited practice, tests, analysis, you can ask your doubts, all question papers you will get. So many videos are there to help you understand complex concepts in a very interesting manner. So if you've not downloaded the app yet, go ahead and right after this class, download it. Great, good to see that. A lot of yes, a lot of me. Awesome. Thank you, Tatleen. Hey Swaraj, good to know that. Legend Girl is saying, ma'am, let's start. But before I directly dive into the session, before I kickstart, you need to tell me something. Is this PPT working fine? Can you hear me, see me? Fatafat say, give me a green signal and then we get started. Good afternoon, all of you. So good to have you back. Nice. Awesome. Quick thumbs up coming my way, which means we can get started. Yes, I can see that. Super duper excited. Awesome. Alright, how many of actually registered for the scholarship test as well? Let's see. I really want to know this actually. Registration is for free, by the way, and every Sunday, like these tests are being organized. You can pick up any Sunday and go appear for this test. You'll actually understand about your conceptual knowledge. That's very important. What are the gaps? Where are you lacking? What can you improve? All these things. This is for students who are in grade 4, 5, 6, 7, 8, 9, 10, 4 to 10, all of you, all boards inclusive. So give this BYJU'S scholarship test and understand your learning, understand your performance in a better way. Hey, Rafiq is already registered. Awesome. Good. Good to know that. And of course, yes, you will get subject-wise improvement points. What else do we want, right? We really want to improve. We always want to learn from our mistakes. Hey, Tatlin, good to know that. Alright, since you've given me a green signal, let's get started and let's start with the homework question first. So, this is the homework question we gave you the last time. A form of matter has no fixed shape but a fixed volume. An example of this form of matter is, well, when we talk about no fixed shape but a fixed volume, we are talking about a liquid. Out of these given options, krypton, carbon steel, carbon dioxide, all these and the gases of the solid state, but kerosene. Let's discuss about kerosene here. Janani, Shakil, Chitra, Raj, Prashansa, all of you are voting for the same option. Awesome! Before I started explaining, the answer was out there already. Good to see that. Yes, you people are right about kerosene. So when we talk about kerosene, it's a liquid, right? Being a liquid, obviously, no fixed shape is there, it takes the shape of the container, but it has fixed volume, and this brings us to the correct answer, which is option B, kerosene, and I can see all of you are voting for that. But now let's quickly see who all have actually done the homework question. And if I take your name, a smiley in the comment section or a thumbs up in the comment section to let me know that yes, we are present today as well. Okay, let's begin. And this time the list is endless, I think. So I'll quickly take the names. Krish, Ainita, Saranya, Angsumi, Venkat, Vartika, Prachi, Chitramani, Joe Anthony, Archit Chaudhary, Hansika, Om Shankar, Aditi, Milan, Malik Arjun, Arshia, Arushi, Adrita, Tanisha, Madiha. Study notes, what's your name? Prashansa, Yuvraj, Rafiq Ahmed, Sonal, Rashmi Dwivedi, Jayati, My Diary. I remember. My Diary is present today. Okay. King, Ayan, Shivansh, Dheeraj, Pooja, Jivita, Memento, Zarina. So many of you. Good. Awesome. I can see a lot of thumbs up, a lot of smiley. The ones who've done the homework. And if you've not done the homework, yet you have, somehow given the answer right on the chat box, you can also post loads of thumbs up. If you've understood the answer, if you've understood the approach to arrive at the answer. Great. Thank you. Thank you for giving me this green signal that you've understood this concept. Alright, so what are we going to cover today? Today, we will be talking about some very, very important processes. We'll be talking about melting, which is also known as fusion. Then we'll be talking about solidification. This is also known as freezing. Then we'll also be talking about vaporization. And finally, condensation. All these things we'll be talking about today. And we have a homework question also for you. No, Mona Lisa, we're just getting started. And to begin with, I want to ask you a question. Can you think matter can change its state? What do you think? Like, can you think of a substance that can exist in all the three states? Let's see. Zarina says yes. A lot of you are saying yes. Like, I know what's running in your mind. I want you to write it over there. Any substance. Shakil says water. Rafiq, Vartika, a lot of you saying water. Alright, yes. So, can matter change its states? I'll take it to be a yes then. Yeah? Okay, so over here, we can find that in nature, water can actually exist in all the three states. We've got solid ice, we've got liquid water, and we've got water vapor as well. Now the important point is, how are these states interconverted? What is the role of temperature in this interconversion that is taking place? And that is what the session is all about. Now, to answer this, a very, very simple question I have for you again. To answer the previous one, I've got another question. How do you convert, say suppose you have a glass of water at home, it's obviously in the liquid state. How do you convert it to ice? Right now it's in the liquid state. If I ask you that I need to convert it to ice, what are you going to answer? What do we do at home? Freeze it, cool it. Yes, correct. So in a way we are cooling it. And what is cooling? It is basically decreasing the temperature, lowering the temperature. Yes. Now, if you have to convert it to water vapor, what are you going to do? You will obviously heat it. Now, when you heat it, what are you doing? You are in a way increasing the temperature. Yes. So, by decreasing the temperature, by cooling it, you can convert water that's in the liquid state to ice. By heating, by providing some heat, by increasing the temperature, you are converting it to water vapor. Yes? So, definitely, what we can conclude from this is that over here, temperature can change the state of matter. Now, let's get in the depth of it. Let's understand this from the scratch. Alright, over here, we have a burner and you have to see what's the effect of temperature on ice. What is happening? We've got a beaker which contains ice, some heat is being provided. What do you observe? What is happening? Yeah, we are increasing the temperature. Ice is melting. Okay, ice is converting to water. Yes, correct. So, ice is converting into liquid water in a way when we are heating it. That means when we are increasing the temperature. So, heat energy basically increases the temperature and solid ice gets converted to liquid water. Yes? Correct. And this process of conversion of a solid to a liquid is known as melting or fusion. So, what is happening over here? Solid is in a way getting converted to liquid. Yes? Correct. Now, what's the role of temperature? Definitely there has to be some role. We are heating it, we are increasing the temperature, we are changing the temperature. So how is temperature helping us in the process? Let's understand this. Now, over here, what do we have? We have ice, which is a solid, right? Now the particles can vibrate about their mean position. Okay. Why? Why is there just vibration and not movement? You have to keep answering, you have to keep replying. Dheeraj says they are closely packed. Yes, the force of attraction is too much and space is negligible. So if we take any two particles or take random particles, you will realize that force of attraction between the particles is too much, right? Force of attraction is so much over there. Correct, correct, closely packed, tightly packed. Yes. And space is negligible. Yes, you people are right. So, over here, we know what's happening in ice. Now, when we keep increasing the temperature, so what are we doing? We are in a way increasing the temperature. Now, if we keep increasing temperature, vibration is also going to increase. Yes, so clearly vibration of particles are increasing as the temperature is going up, as we are providing heat. Now, over here, keep noticing what happens to the force of attraction. When this is the situation, what do you think is going to happen to the force of attraction after providing this heat energy? Weakens the force of attraction between particles, correct. So, force of attraction between the particles is in a way weakening, it's becoming less and ice melts at this point of time. Yes, There's somebody named Besties giving all the right answers. Great. Correct. And you can see that ice is going to melt. Now, over here, ice is melting, finally converted to water. In case of water, you will see large interparticle space. Yes. And when we talk about force of attraction, that is going to be comparatively weaker. So, weaker interparticle force of attraction is there. So, from a solid, we've reached to a liquid. Hi, you've just joined in. Welcome. Yes, quickly let your friends also know about the session. Great. Alright. Now, look at this carefully and tell me the temperature at which you think ice is melting. Really simple question, huh? Let me check your observational skills. Temperature at which ice is melting. Janani is the first one to answer. Let's wait for some more seconds. Let's see who all. Jainil has also answered. Bhakti, Shivansh, Venkat, Ayushi, Prachi, Monalisha, Gargi, Madhumitra, Anchal, Rafiq, Shivansh, Krisha, all of you are saying that ice is melting at 0 degrees Celsius, which is correct. And this is known as the melting point of ice. Now, there's a new term that I'm using, melting point. Let's understand what is the meaning of this term. So, it's the minimum temperature at which a solid melts to become a liquid at atmospheric pressure. Some things are very, very important in this definition and we need to understand what we are saying. One is this term atmospheric pressure and there's another term. So, you people just told me that in case of ice, it was 0 degrees on the Celsius scale. Let's understand these two terms over here. Right? Let's understand what is atmospheric pressure, what is Celsius that we are talking about. Yeah, correct. Yes. So when we, yes, Shakil, when we talk about, say suppose we have ice. Yes, and ice is melting to form water. So in a way ice is melting, right? It is going to have a melting point. When we talk about water converting to ice, what is happening in that case? Think about this and you will get the answer. Yeah. Alright, so atmospheric pressure and Celsius scale, two things that we have to cover. Really, really important point, we'll start with Celsius scale. And we mostly use Celsius and Kelvin scale. We all know about this, right? The amazing part is any temperature that is there that we have in the Celsius scale can easily be converted to the Kelvin scale and vice versa, right? So, there's a very simple formula to do that. Yes? Are you all ready? अच्छा हिंदी में भी बता देते हैं हम नॉर्मली टेम्परेचर कैसे मेजर करते हैं सेल्सियस में भी करते हैं केल्विन में भी करते हैं सो जो टेम्परेचर है वो हम इजीली कन्वर्ट कर सकते हैं सेल्सियस स्केल से केल्विन स्केल पे यस एंड फॉर दिस वी हैव अ वेरी सिंपल formula. We have a really simple way to convert these temperatures, that is temperature in Kelvin is equal to temperature in degrees Celsius plus 273.15. Now just to make your calculations simple, you can also take it to be as 273 only, like you can let go of the 0.15. So temperature in Kelvin is almost equal to temperature in degrees Celsius plus 273. Correct, yes. Yeah, so if you are being given the temperature in Kelvin, you can use this. In degrees Celsius, you can again use this. Yes, you can always take there on the opposite side and subtract. Yes, absolutely right, besties. I'm still waiting for your name. Okay, now that you've understood this simple formula, quickly tell me, if the temperature is 2 degrees Celsius, what's going to be the temperature in Kelvin? Let's see who's going to be the first one to answer this. First one to answer. Temperature given to you is 2 degrees Celsius. Janani, Rishikesh Kumar. Okay, a lot of you are giving the answer. Ayushi, Madhumitra, Kalyani, Gargi, Grisha. Yes, you have given the correct answer. All you need to do is put this over here in this formula. So, for the temperature in degrees Celsius, 2 is the value given to you, plus 273, giving you 275 Kelvin, and that's going to be your final answer. Yes, and please note over here, when we talk about this, don't write Kelvin in small k. It is going to be capital K only. This is wrong, okay? Yeah, and same goes for degrees Celsius. Don't write degree Kelvin. That is also wrong. Don't write degree with a small c. This is also wrong. It has to be degrees Celsius with a capital C. Little mistakes that we do, small mistakes that we do. So be careful about all these. Chitra is saying, got it, and let's move on. Oh, you're giving in decimal. Great. All right. Now coming back to our definition of melting point. We said it's the minimum temperature at which solid is melting to become a liquid at atmospheric pressure. Now melting point of ice, we know that it's 0 degrees Celsius, right? And you can convert it to Kelvin scale as well. So it's going to be 273.15 Kelvin to be very precise. Okay, we know about this now. But there was another term, atmospheric pressure. So let's understand what this means. Now we know Earth has different layers, right? It has different layers of atmosphere. The pressure of air in atmosphere is known as the atmospheric pressure. Really simple, really basic, right? So there you go. That is what is atmospheric pressure. In a way, you can say force per unit area exerted by atmosphere. That is going to be atmospheric pressure. Now, we can actually measure this in atmosphere. You must have seen this written at some point or the other, maybe on Google or somewhere, ATM. So you can measure atmospheric pressure in atmosphere. Correct. Yes. I can see that. Yes, Yashwant. Hey, Himani. 2 states at 0 degrees Celsius. Coexisting. Yes, we'll come to that point. Don't worry. Alright, now when we talk about atmospheric pressure, it's not the same everywhere, right? At the sea level, it is 1 atm. So at sea level, you can see it is 1 atm. But actually, it decreases with the increase in altitude. So, as the altitude keeps on increasing, this value will keep on decreasing. Now that we've understood about melting, I have a question for you. I've got 2 solids. First of all, I want a quick thumbs up if you're ready for the question. Let's see. What is sublimation? We'll come to that. Unit. Loads and loads of thumbs up. Okay. Then you are super confident to answer it, right? I'm assuming that. So, you have over here ice that is melting at 0 degrees Celsius, and you have wax on the other hand, and that is melting at relatively higher temperature. My question to you is, both are solid. Both are solids, right? Both are melting. Why are they melting at different temperatures then? What can you say about this? Why are they melting at different temperatures? Himani has already answered. Well done, Himani. Correct, depends on that, yes. Force of attraction, Monica is also saying that. Prashansa is also saying that. Zarina is also saying that. Alright, yes, so it is due to the difference in the interparticle force of attraction. Now in case of ice, this attraction, interparticle force of attraction is in a way weak as compared to wax. So in a way we can say that melting point is telling us, it's indicating the strength of interparticle force of attraction. Yes? So if they ask you, is this a parameter, is this a basis? Yes, it can be used to decide about the force of attraction. So over here in ice, as we discussed, interparticle force of attraction is weak, whereas in case of candle wax, it is more. So can we say that more energy is basically required in case of candle wax to weaken this force of attraction, because the force of attraction is comparatively stronger. So more energy is required, and in a way the melting point is more. So yes, you can see that melting point is somewhat indicating about the strength of force of attraction. Yes, Shivam, I can. Hey, Neeta, good to know that. Alright, crystal clear till here? Can we move on? It's okay, not a problem. If you're just joining in, you can always go back and watch the video. Great, I can see a yes, so let's see what do we have next. Okay, did you notice that during the process of melting, as you can see over here, ice is melting. Now the temperature has reached 0 degrees Celsius, but it's in a way constant at this temperature for some time. Why is that happening? What do you think? Why is this happening? You know, till the entire conversion is not taken place. Whole ice into water. Yeah, correct. So after 0 degrees Celsius, we notice temperature is not increasing, even though you can see that we are constantly providing heat. Burner is burning, heat is being provided, still temperature is not increasing till this entire conversion is not taken place. So where do you think is this heat going? Correct. Yashwant, absolutely right. King, Prakash. So this hidden heat, and this hidden heat is basically your latent heat. So let's understand this concept now. Correct, yes. Let's understand the concept of latent heat, which is the hidden heat. Why are we calling it hidden? The reason being, we are constantly providing heat, yet the temperature on the thermometer is not rising. So in a way we say, okay, the heat is hidden, and the name given to it is latent heat. So let's understand what exactly is happening over here. So we've got ice, which is like in the solid state, right? And obviously it has very strong force of attraction. Now when you provide heat, when heat is being given, as you saw, what is happening? All this heat that is provided is used up in changing the state. And what's the state change in this case? It is from solid to liquid. Yes, and this is happening by overcoming the force of attraction. Now during this time, till the time, you know, this conversion is taking place, we do not see any increase in temperature. So now you know what is happening. Yes. And since, by the way, this heat is related to the process of fusion, so we can call this as latent heat of fusion. So in the exam, if this question comes, just don't write latent heat. Write the full one, latent heat of fusion. So yes, all the heat that is being given is used in changing the state by overcoming the force of attraction. And this is your latent heat of fusion. To be very precise, this is how we define it. So it's a heat energy required to change 1 kg, 1 kilogram of a solid into liquid at atmospheric pressure at its melting point. And I hope you know about all the terms that we're using in this definition. Melting point, atmospheric pressure, solid, liquid, heat energy, everything. I can see, yes, absolutely right. Got it. Chitra is saying got it. All right, all right. Okay, you want me to explain this again? I'll do this again. So, there's a burner that's providing heat, right? Heat is constantly being provided, yet we notice that the temperature on the thermometer is not going up after it has reached 0 degrees Celsius. Why is that happening? The reason is all this heat that is being provided is being used up to overcome the force of attraction, to change the state. Once the state changes, then of course the temperature would go up, but till that time, till the whole ice is not converted to liquid, the temperature is remaining constant, and all that heat that we are providing is being used to overcome the force of attraction. Yes, it is helping in state change. Alright, now that you've understood this, what do you think? From a solid, we've got a liquid. Can a liquid be converted back to solid? Yes, Vishal, we'll let you know about the free trial class very soon. I see a lot of you saying yes. Can you figure out, can you think of the name of the process? Jayashri has already answered. Solidification, correct. And in this, basically, it's the process of turning a liquid into a solid. And to know more about this, you have to download Byjus, the learning app. And you will get all the amazing concepts over there in a very super amazing way. Yes. So right after this session, download this app quickly and understand this process. Visualize this, understand this, and I'm sure you'll really like it. No all-rounder, not at all. Hey Jayashri, good to know that. Hey Yashwant, nice to read that. Zarina, homework question discuss ho gaya. We'll give you another homework question towards the end. Alright, so let's quickly, summarize what we've understood till now. From a solid to a liquid, when we are going in a way, we are heating and increasing the temperature. The process is melting. To do the reverse, from a liquid to a solid, we are in a way cooling. That means we are decreasing the temperature, and this is solidification. Now it's time to further continue heating, right? Let's continue providing heat to the system. Ice has converted to water. What happens if now also we continue providing heat? So let's understand this. Over here, the temperature is going up, as you can see. Yes? And when heat is being provided, when temperature is increasing, liquid water gets converted to vapor, and this process is known as vaporization. Correct. Absolutely right. Hey, there's a difference between boiling and evaporation. We'll come to that really soon. Vaporization, correct. Yes, absolutely right. Now, here, what do you have? You have a beaker. In this beaker, we have liquid water. So, particles are actually moving here. Yeah, why are they moving? The force of attraction is comparatively weaker, and of course, we've got the moving particles here and weak interparticle force of attraction, as I just told you. Now, when you continue providing heat, when we increase the temperature, so what are we doing? Remember this, that we are increasing the temperature. When we continue increasing the temperature, heat energy in a way weakens the interparticle force of attraction, and thus the liquid state of matter in a way gets converted to the gaseous state, and in the gaseous state we all know particles are moving randomly. Yes? Can you see that? Correct. Absolutely right. So in the gaseous state, obviously they have almost like negligible force of attraction. Chitra, besties, Neeta, I guess. Manjeet. Good to see that. Alright, yes, they're freely moving, correct. Now, when we continuously provide heat, water that you have over here, it's going to start boiling, right? And water boils at 100 degrees Celsius. This is known as the boiling point of water. So now it's time to understand what exactly is boiling point. Now when we talk about boiling point, it's the temperature at which a liquid starts boiling at atmospheric pressure. Really simple. But I know where you get confused. Boiling and boiling point, these are two different things. They are interrelated, but they are different. When we say boiling, that's a process. When we say boiling point, that's a temperature. So understand this and don't intermix the definition of both of these, okay? Quick thumbs up if everything is clear till here so that we move on. Hey, you're in grade 7. Then I can hope you're understanding all this. Yes, all-rounder, we're going to come to that really soon. Good. Good to see you've understood the concept. Alright, for water, really simple, no rocket science in this. The boiling point is 100 degrees Celsius, and I'm sure you can convert in the Kelvin scale as well, 373.15 Kelvin. Even if you write 373, that will do. Great. Alright, now again, we have the source with us. We are constantly providing heat. Heat is being given continuously, but after 100 degrees Celsius, the temperature is not increasing till whole water is converted to vapor. Again, you know my question. Why do you think this is happening? What do you think is happening over here? Rajan is the first one to answer. Let's see what other people are going to guess. Janani has also answered. Mahamaya, King, Gargi, Vartika. Yes, PDFs will be provided. Ayushi, Prashansa, Yashwant. All right. Now you people are answering. So yes, hidden heat concept is back. Latent heat. Correct. Now, over here, temperature is remaining constant. We'll come to that. So water, as you can see, is obviously, it's a liquid, right, and has comparatively weaker force of attraction. Now when we heat it, what's going to happen? This heat energy is basically getting used up to change the state, and this time, what is the change in state? From liquid to gas. This is the change in state that's happening by overcoming the force of attraction, and during this process, we do not see an increase in temperature, and even though we're providing heat constantly. So same logic we are applying over here. Heat is constantly being provided, but all that heat is not increasing the temperature. Instead, it's getting used up in the state change from a liquid to a gas, or of course, in case of water, we're talking about water vapor. This is again latent heat, and since it's linked to the process of vaporization, we call this as latent heat of vaporization. Heat energy required to change 1 kg of a liquid into gas at atmospheric pressure at its boiling point. Yes, Rupa, absolutely right. Okay, if you've understood everything till here, I again have a question for you. I know I keep shooting a lot of questions in between, but that's just to ensure, that's just, to make sure that you people are understanding everything. Can I ask you this question? Tell me. Everything clear till here? Thumbs up so that I ask you the question. Ayushi ने बोल दिया yes ma'am, बिल्कुल पूछो. Alright, now I'm getting a lot of yes, so let me ask you this question. So, you must have, noticed this in the kitchen at some point or the other. Cooking ho rahi hai. Why are water droplets formed on the lid? When you pick up the lid, why are water droplets formed over here? This is my question. Let's see who's going to answer this. I can already see a lot of you are answering. Most of you are giving me this answer of condensation, but I saw somebody write evaporation also. किस आंसर को फाइनल करें? Which answer should I log? Condensation or evaporation? Okay, let's go with majority in this case. Alright, so condensation is actually the correct answer. The process that is happening over here is condensation. Now, when we talk about this, what is happening? Vapor becomes liquid, right? It's just the opposite of vaporization. Vaporization mein, what was happening? Liquid was getting converted to vapor. In condensation, vapor is getting converted to liquid. That's why you get the water droplets. So if you are the one who actually guessed this right, if you've written condensation, post smileys so that I know कि हाँ किस किसने सही answer दिया. so that I get to know who all have answered it correctly. Let me see how many of you are smiling right now. Hey, Janani is really happy. Rafiq, Ayushi, Chitra, Tatlin, Lakshmi, Shashwant, Prashansa, Anchal, Vidhi, Venkat, Gargi, Anshi, Lavanya, Utkarsh, Vishal, Zarina. All right, all right. Some of you are laughing, some of you are happy, some of you are dancing. This makes my day. So let's quickly summarize what we've understood. So over here, from liquid to gaseous state, basically if it's vapor also, heating is taking place and the process is vaporization. From vapor, if you cool the vapors, in a way you're getting back the liquid, condensation. So I understand this has been a heavy class, so many new terms are there, so many new processes are there. Let everything sink in. Yes, come back to the session, revise everything again, master all these topics. When you will keep watching the visuals, I'm really sure, in a very natural way, in a very organic way, everything is going to go here. It's just going to sink in. Great. Awesome. So if you're very much clear about melting, solidification, vaporization, condensation, I want 4 thumbs up in the comment section. And then I will tell you what's the homework question. Yes, definitely you can get that. Zarina has given 4 thumbs up. She's understood it. Himani, Lakshmi, a lot of you. Great, awesome. Then quickly like this video as well so that I know that yes, you people have found the session informative, found the session interesting. Awesome. I can see a lot of you liking the video right now, which is simply great. And the homework question is right in front of you now. What is the difference between boiling and evaporation? And you can mention your answer in the comment box below after this session. We will be discussing in detail what is boiling, what is evaporation. Don't worry about that. But what is your understanding of this question? This is what we want to know from you first. I think these 2 terms are similar in a way, yet different. And I want you to figure out what makes them different. So it's in a way boiling versus evaporation. When is water boiling? When is water evaporating? Take the simplest example. I'm sure you'll be able to understand in a better way. And with this, we've come to the end of today's session. But hey, we can always connect on Telegram as well. So this session PDF, all session PDFs, everything is there. All the updates are there. Quiz, homework questions, revision questions, everything is going there. So please join Telegram as well. The link is there in the description box. You can go and check that out. And of course, we've definitely got you covered. We keep telling you this because we are really planning a lot of things for you. And we'll make sure that learning is a wonderful experience for all of you. So yes, we've got you covered and we'll help you ace the exam for sure. Now coming to BYJU'S classes with 2 teacher advantage, and you can clearly see the highlights, right? Homework, testing, reporting, PTMs, all these things are there. BYJU'S classes is offering everything out there. So go ahead, the link is there in the description box. You can try this free trial class as well. And it's absolutely free. So what's the harm? You can go and always try that. Yes? Awesome. And of course, last but not the least, don't forget to like this video, subscribe to the channel and hit the bell icon as well. Yeah? I hope you've done all 3 already. Great. Alright. Thank you so much guys for this amazing session. Keep exploring the magic of chemistry and I'll see you in the next session. Take care. Bye-bye.